Welcome back, critical thinkers. Hopefully, after our last discussion, you were able to go out there and practice sampling. If not, I understand. Hopefully you did, just to sort of prove to yourself, and not just taking my word for it, that sampling works. Well, our topic for today is scientific research. And this is really all about inductive reasoning too. This is going to be today a discussion of different ways of conducting scientific research, because scientific research is sort of the gold standard for how we make good quality observations, because that's the other piece of truth finding from a philosophical standpoint. First, you have deductive reasoning, or once you've agreed on the facts, how do we put those facts together in a logical, sound, valid way? But how do we agree on the facts? And that's inductive reasoning. That is making observations about the world to figure out some general pattern about what is true. And the scientific method, which we sort of started talking about last time when we talked about sampling, is the best way to make observations. Because an individual person's observations, no matter how good an observer, is going to be limited by time and space. One person can only make a limited amount of observations in a limited facet of the world. And so that's why science exists, in order to make good systematic observations using lots of observations from lots of individuals over time. And so scientific methodology has really been established as the best way of deciding what the facts are. And so today we're going to be learning about different types of scientific research. And so make sure you have the lecture notes entitled Inductive Reasoning 2, Research. And let's get started. And so, of course, I always start out with a joke. Volunteers needed for a scientific study, ha ha ha, investigating whether or not people can distinguish between scientific studies and kidney harvesting scams. Once again, this is my favorite webcomic, XKCD. Just poking fun at scientific research. But it's the idea that in scientific research, we're going to gather data from lots of different people. I'm a psychologist, so for me, scientific research is all about gathering data from lots of people, right? But it doesn't need to be people. We gather data from a wide variety of observations, whether it's about electrons or tree growth or climate or people. It doesn't change the nature of it. Good systematic observation. The question then becomes, what is the goal of scientific research, right? So on slide 2, we talk about that. What is the goal of scientific research? And if we're talking about people, it's about understanding people, but independent of that, it's to understand and predict the world. That's the idea. Research is to try to figure out what the world is like, observationally, and then to make predictions about it so we can make good decisions about it, right? That's the goal of research. And so to go back on slide 3 to how research gets done, we've got those 5 basic steps of research. First, identify a characteristic of interest. Let's say I want to study depression. I want to understand and make predictions about people's depression. Who do I want to know about? Maybe American adults. I'm interested in depression in American adults. Whom can I study to get accurate answers? This was our topic from last time. This idea of sampling and essentially how do I get a good sample? And today we're going to be talking about how do I collect that data in a systematic way. We're going to be focusing on step 4 today. What procedures can I employ in order to have really good scientific research? And of course, there are whole classes called research methodology. We're going to only cover it in a single discussion. So what I'm going to choose to focus on is to teach you about 3 broad approaches to scientific research. Because these 3 broad approaches to inductive scientific observation answer 3 different kinds of research questions. So once again, we're right back to questions, issues, reasons, and conclusions. And scientific studies are just very sophisticated examples of issue, reasons, and conclusions. You ask some scientific question, you gather evidence, gather data from individuals or from electrons or whatever. You gather evidence from the world, that becomes your reasons, and then your conclusion based on that gathered evidence is the answer to the question. And there are different kinds of scientific questions that we can ask. So I'm going to teach you about 3 different broad approaches to scientific methodology. And then we're going to touch very briefly on today step 5. So moving on to slide 4. What are the big, broad approaches to research methods? And there are really 3. There are really 3 broad approaches. The first is called an observational approach, where we ask something called a what question in science. And this is the idea is, what is something like? What is a characteristic like? What is a phenomenon like? In a very descriptive way, by simply observing it. The second broad approach is called a correlational approach, where we ask a slightly more sophisticated question. We ask how different characteristics are related. How are variables related? And remember last time we talked about variables. How are variables related to one another? So let's say I want to know about depression. That's my characteristic of interest. As a scientist, I have to decide, what kind of question am I going to ask? Am I going to ask an observational question? What does depression look like? Am I going to ask a correlational question? How is depression related to other human characteristics? Right? So that's the difference between observational and correlational research. And the last broad type of research is called true experimental research, where you can ask something called a why question. For example, using the depression as a working example, observational research might tell you what depression is like. Correlational research might tell you how depression is related to other characteristics. And a true experiment would allow you to say why depression might be related to other human characteristics. And so we're going to learn about these 3 broad approaches to scientific methodology. So moving on to slide 5, let's talk about observational research. In observational research, you simply observe. I mean, it's right there in the name. It's super helpful. Where you don't try to intervene, you don't try to manipulate any of your research subjects, you don't even try to interact with them too much. You simply try to observe a human characteristic, if we're talking about people, in its natural environment. So you can get a really rich description of what a particular human characteristic looks like. And so let's use the example of aggression. And let's say I've identified my characteristic of interest, aggression. I've identified my population of interest, young children. And I've decided to get a good random sample of young children in schools. So now, if I'm going to be doing observational research, it's because I simply want to know, what does aggression in young children look like? And so I simply may engage in something called naturalistic observation. I go to the play yard. I don't tell anyone I'm there. I get a very detailed description of every aggressive act I see those children engage in, so that I can get a sense of what does aggressive behavior look like in young children in a very rich, descriptive way. This is often in anthropology and sociology called an ethnography. Where you actually embed yourself in a particular ethnic group or in a particular culture, and including like the culture of a play yard, right? The ethnography of a childhood play, right? So I might get a job as a teacher, or I might get a job as a volunteer aide, and then make a detailed description of everything that I see on the play yard. And that would be an example of observational research. I'm not trying to interact with the kids. I'm not trying to get the kids' behavior to change in any way. I'm simply getting a rich description of what I see. So moving on to slide 6, let's sort of talk about the good things about observational research. The good thing about observational research is that it has something called external validity. That means any inductive generalizations you make, any inductive observational-based decisions you make are going to be true in the external world. Like, for example, if I see hitting as a very common childhood behavior, that would be externally valid. I say, hey, kids, when they're angry, they hit each other. And that sort of inductive conclusion, based on my observation, is going to, in fact, be true in the real world because I went out in the real world to make that decision. Another good thing about observational research is that it's often a good very first step in a new research domain. And that means a new area. A domain in research means like an area of research. And so if I'm interested in aggression in children on the play yard, then my domain is the children on the play yard. It's just a sort of fancy way to say, what topic are you studying, and specifically what area of that topic are you studying? And whenever you study something that's new, in a new thing, observational research is almost always the best place to start. So let me give you an example of that. I have historically done research on something called online pro-social behavior. What does that mean? Well, that means in online settings, I'm interested in people that do nice things for each other. People who engage in like volunteer-like behavior in an online setting. So think like Wikipedia. People basically volunteer their time to edit articles and try to give good information to Wikipedia for absolutely no money. Or when people go onto Yelp to make a review, they don't get any pay from it, they don't get any direct benefit, but there's this sort of pro-social orientation in this online environment. And that's been a very new topic, right? Because there wasn't an online environment 25 years ago. There was no such thing. There wasn't the internet as we currently understand it. And so when people first started studying these sort of pro-social, positive, volunteer-like behaviors in online settings, the very first step was just to describe it. What are the kinds of things people can do in an online setting? What are people, in fact, doing in an online setting? And so simple observational research was required. Describe what Wikipedia looks like. Decide what other websites look like when they allow people to engage in pro-social behavior in a very externally valid observational way, where you're not even systematically tracking individual people. You're simply getting a broad observational snapshot of what a particular characteristic looks like. And so it was a good first step. The downside of observational research is because you're just sort of getting this rich, holistic description of the external world, you're not systematically tracking people in any systematic way such that you can say, hey, answer these 5 questions for me or answer these 50 questions. You can't do that in really good observational research, because once you start saying, hey, I want you to answer my questions, you're not getting people as they naturally exist. You're bringing them in and asking them questions, and so that's less of true observational research. But because you can't do systematic tracking, you can't ask how questions. Like, let's say I wanted to know how aggression was related to other variables. I wouldn't be able to do that because I wouldn't be able to systematically track aggression along with other human characteristics in the same individuals. So I couldn't make objective statements about how things might be related. Observational research, if it's true observational research, also can't make statements about why variables might be related, right? So it's a good first step. It has something called external validity, but it's limited in the kind of questions it can ask. It can only describe what characteristics look like. It can't say how those characteristics are related to other things, and it certainly can't say why some variables might be related to other things. And so let's use another example. Let's say I'm on the play yard and I'm tracking aggression. And I'm looking what aggression looks like in young children. I get a rich description of what aggression looks like. And let's say I'm also tracking popularity. And I'm going, what does popularity look like in young children? If I'm not intervening in any way, if I'm not systematically tracking each individual child and the specific amount of aggression that they have and the specific amount of popularity they have, because I'm simply engaging in naturalistic observation, then I'm limited. I can get a rich description of popularity. I can get a rich description of aggression. But if I'm just engaged in fly-on-the-wall observational research, where I'm just describing something in detail, I can't ask how popularity and aggression might be related. In order to do that, I have to do what's called a correlational research study, where I can describe the relationship between popularity and aggression. And sometimes observation can be used to do correlational research. But what makes correlational research correlational is systematic tracking in each individual child exactly how much aggression they're engaging in, exactly in how much popularity they seem to have. And once you take that more systematic step, you sort of lose rich description. You're not describing an entire scenario where child A interacted aggressively with child B. You don't have a rich description of that event. Rather, you're systematically tracking how many aggressive acts did this child engage in. How popular is this child in a systematic way? Because you're asking the question, within a group of children, is there some systematic relationship between popularity and aggression? And once you do that, you're having to track aggression in a very specific way and track popularity in a very specific way. And you sort of lose on that rich description that observational, naturalistic observation buys you. And in order to do correlational research, you have to essentially do something called create an operational definition, where you have to operationally define what you mean by aggression. And you have to operationally define what you mean by popularity. So instead of simply getting a rich description of these two psychological characteristics, you have to decide what you mean specifically by aggression. And you have to decide, what do you mean specifically by popularity? And then track it in a systematic way. And then once you do that, moving on to slide 9, you can calculate this number called a correlation coefficient, because that's what a correlation does. Is it allows you to systematically track the number of aggressive acts a child engages in and systematically give people a number for popularity, and then do these things called correlational statistical analyses, which we're not going to do in here, that sort of allows you to estimate how strongly two human characteristics that we call variables might be related to one another. And so once you've systematically tracked popularity and given someone a number for how popular they are, high versus low, and then systematically tracked childhood aggression, giving a child a number for aggression, high versus low, within each child you can track both their popularity and their aggression, and then calculate this number called a correlation. You want to know how to calculate it? Take a good stats class. In here, we're simply going to learn about what a correlation is. It's a number that can range anywhere from -1 to +1. And the symbol that's used is R. So we say the correlation between two variables is R equals some number, right? And that number then represents the strength of the systematic relationship between two variables. So for example, my shoe size in American measurement, size 7, and my shoe size in Italian measurement, I think it's like 32, are perfectly correlated, right? Just like your shoe size in American measurement and your shoe size in Italian measurement would be perfectly correlated, right? Higher scores on American shoe size is going to go with higher scores on Italian shoe size perfectly, right? And so that indexes the numerical relationship between these two different shoe sizes. It's a perfect relationship. And so when you systematically track mathematically with numbers human characteristics and then calculate the correlation, numbers that are closer to +1 or -1, we say are very systematically strong. And you can have both positive and what are called negative relationships, right? And the strength of the relationship is simply how close is it to 1 or -1, right? So -0.75 would be a very strong relationship. Positive 0.75 would be equally strong, just in what's called the positive direction, right? So -0.75 is stronger than 0.5. And any correlation close to 0, we say, no relationship. So let's explore this a little more in slide 10. And so let's give me a couple of examples of things that are positively related. And so you would end up with a positive correlation. So a positive number of like 0.5 or positive 0.25 or positive 0.6 or positive 0.7, whatever it is. Correlations above 1 can't exist, right? Correlations mathematically can't be above 1 or less than -1. You want to know why? Take a good stats class. So let's think of two examples of variables that have a positive relationship. And so if we look at this graph on slide 10, I have two examples here, similarity and liking, and SAT scores with GPA, right? How similar someone is to you probably means you're going to like them more, because people tend to like people who are similar to themselves. Also, SAT scores tend to be positively related to GPA. And so what a positive relationship means is that within a group of people, if someone has high scores on one variable, they're likely to have high scores on the other, kind of like SATs and GPA. People who tend to have higher SAT scores also tend to have higher GPA. Higher SAT scores tend to go with higher GPA in individuals. Lower SAT scores tend to go with lower GPA in individuals. Same thing with liking. The more similar someone is to you, the more likable you probably think they are. The less similar someone is to you, the less similar the less similar someone is to you, the less you probably like them. Or how about exam grades and studying? The more you study, the higher your exam grade's going to be, right? And so if we see this top graph over here on the slide 10, if you look at each of those shapes, I've got a red diamond, a yellow square, a green triangle. Each of one of those shapes represents a person and their score on two different variables. So let's say along the x-axis, which is the horizontal one, is how many hours you study for a particular exam, right? And I've got 0, 2, 4, 5, 8, and 10. Along the vertical axis, the straight line there, along the vertical axis called the y-axis, y by convention, if we look at that axis, from 0 to 80, we're tracking people's exam grades out of 80. And we see somebody who studied for 2 hours, that's my yellow square person, got a very low score. Got only it looks like a 10 on that exam. Ooh, not good. But somebody who studied for, looks like 14 hours, my little pink diamond there, got a 70 on the exam, right? So there's this positive relationship between the number of hours you study and your exam grades. People who study more had higher exam grades. So the number we calculate would be positive because both variables are moving in the same direction as a pattern. So the number you calculate would be negative, right? And in this case, it's a perfect relationship. A negative correlation just goes the other way, where as among a group of individuals, those with high scores on one tend to have lower scores on the other, right? So let's think about like how much time a couple spends arguing and how happy they are with their marriage. Where it seems so, and let's say we're tracking that here, where there are 0 fights along the horizontal x-axis, and there are marital satisfaction from 0 to 80 along the vertical y-axis. And so we have a person who fights about 4 times a month, right? My little green triangle person. 4 times a month, and they have a marital satisfaction of 60 out of 80. You know, 4 little arguments a month, probably not a big deal. Then we zoom over here to a person who reports 14 arguments a month. Whoa, 14 arguments in a month. And you can see their marital satisfaction, my little pink circle, is at is around 5, right? So those individuals who were reporting more conflict were reporting less marital satisfaction, which gives us this negative correlation. And if you know anything about math and you know anything about lines, you'll actually know that the slope of these lines is positive when variables are moving in the same direction, which is why we call it a positive correlation. And the slope of this relationship for the negative correlation is moving in the negative direction, right? This is one of those neat things in life where math actually maps onto real world relationships. If you're not a math person and have never taken a math class, just remember that if higher scores on one variable go with higher scores on the other, it's called a positive relationship. That doesn't mean good. It just means they're moving in the same direction. That's called a positive relationship. But if scores on one variable tend to systematically going with lower scores on the other variable, we call that a negative relationship, right? So if it's in the opposite direction, we call that negative. Doesn't mean it's bad. It just means it's in that negative relationship pattern. So, and what I've mapped for you here on slide 10 is a perfect relationship, right? In the real world, things are not going to be as clean. So here on slide 11, I've just shown you messy data. Again, each little individual shape is a person, and the graph on the top is still going to be a positive relationship. Because in general, let's say this is study times again, study times and exam grades. In general, we can see people who study more, right, are getting higher exam grades. But then we look at our little yellow triangle person and our black square person who both studied kind of a lot, right? And they both got a 70 out of 80 on the exam. But the person with the black square studied more than the person with the yellow triangle, and yet they got the exact same exam grade. Because that happens in the real world, right? That happens, but you can still see the general trend here. The general trend of more studying going with higher exam grades. So this would still reveal a positive relationship. And so the number we would calculate, called the correlation coefficient, would be in the positive direction. The graph below it, on the other hand, would indicate no relationship at all. Right? So this might be shoe size and exam grades, right? Where you look at two people who have generally the same shoe size. My little green triangle person and my little yellow square person. Both of them have roughly the same shoe size, between 2 and 4. And one person did much better in the exam than the other. You go over here to the high shoe sizes. Two people with a size around size 12. My little yellow triangle person and my black square person. Very similar shoe sizes. Wildly different exam grades. And so there's no relationship here. And you can see there's not really any pattern here with high scores on one going with systematic, any kind of scores on the other variable, right? And so we can sort of eyeball these graphs to sort of estimate what that number might be. If you want to be able to calculate correlations exactly, again, take a good stats class. For the purposes of our class, I just want you to know that in order to do correlational research, in order to ask how variables might be related, do higher scores on one variable tend to go with higher scores on another, or do higher scores on one variable tend to go with lower scores on the other, you have to systematically track the world and actually numerically keep track of people's behavior. And then you can calculate these things called correlations. They're statistics. And so to use my example from a few slides ago, if I was looking at popularity and aggression, right? Popularity and aggression, I would need to systematically track aggression and then systematically track popularity, because it might be that the kids who are more aggressive also tend to be more popular. Or it might be the reverse. The kids who are super aggressive tend to be less popular. The only way to ask that how question would be to do a more systematic tracking of behavior and then compute statistically a correlation. So, hopefully at this point we have an understanding of what correlations are, right? What correlations are and how we can systematically track them. But now for the downside of correlational research. Correlational research can tell you how two variables might be related. For example, the popular kids tend to also be the aggressive kids, or the popular kids tend to not be the aggressive kids. Let's assume that the popular kids are also aggressive. I like to imagine the movie Mean Girls, where the popular kids are also super aggressive. If you have not watched Mean Girls, it is an excellent movie. I highly recommend it. But in any case, let's say I go with that working assumption. There's some competing explanations here, right? It could be that the reason why the popular kids are also the aggressive kids is because being popular somehow gives you the freedom to be aggressive, right? So imagine the cause and effect relationship is that the popular kids, because they're popular, they just feel totally free to be jerks. But maybe not. Maybe it's that somehow being aggressive makes you popular. Maybe the more aggressive kids get more social power or something like that, and so they end up more aggressive. They end up more popular. Maybe the cause and effect flows that way. Or maybe it's some third thing altogether. Maybe having really rich parents makes you really rich parents who never have any time for you, makes you not only aggressive, but also super popular because you have a lot of money. I have no idea. I'm not suggesting any of these things are true. I'm just suggesting that there are competing explanations for why there might be a relationship correlationally between two human characteristics, right? And so let me give you an example in slide 12. There is, in fact, if you track the days of a year, a strong positive correlation between ice cream sales and the murder rate. What? Am I just making this up? I am totally not making this up. If you track all 365 days of the year, day one, how many ice cream sales, what is the dollar amount of ice cream sales? That's a number, high to low. And then you also track the murder rate. How many murders were there committed this day? On days when there are higher ice cream sales, there will also be more homicides. It's a real correlation. It really exists. I'm not making this up. And this is particularly true in big metropolitan areas. On any days when there is more ice cream sales at Baskin-Robbins, Tutti Frutti, in the grocery store. On any day when there's higher ice cream sales, there will be higher murder rates. On any day when there's lower ice cream sales, there will in fact be lower murder rates. And this tends to be a fairly systematic relationship, a fairly strong, robust correlation. So what's going on here? Well, let's explore and how although the correlation reveals how these two variables are related, it's a positive relationship, I promise. It can't tell us why. It can't tell us why there's this relationship between these variables. So let's wrap our head around that. Let's wrap our head around that. So, what's one explanation? Slide 12. Maybe something about eating ice cream is causing people to become homicidal. I like to think of this as the Ben & Jerry's has a new ice cream flavor hypothesis. That they have a new ice cream flavor, toothpaste and orange juice, which I can't imagine a more terrible ice cream flavor. And eating this ice cream has been causing people to become homicidal, running out and committing a bunch of violent crimes. Right? So the flow of causality I'm suggesting is the cause of ice cream sales is having the effect of making people engage in murder, which is causing this positive correlation. That's one explanation. What do you think? What do you think? What do you think of my Ben & Jerry hypothesis? No? How about this one? Slide 13. Maybe the flow of cause and effect flows the other way. Maybe engaging in murder is causing people to then need to go out and get therapy, or maybe the family members and the victims of those who've been a victim of violent crime. And I'm not trying to make light of violent crime here. I'm just using it as an example. Maybe people who are the victims of violent crime, or maybe the family members, or maybe the murderers themselves are going to eat ice cream after they engage in homicide. I like to think of this as my Dexter hypothesis. Right? Dexter is a television show about this kind of sort of sociopath who feels really terrible about the fact that he does it, but so he comes up with this good reason why he's doing it. So I like to think of this as my Dexter hypothesis, where people who engage in murder, because they feel so terrible about what they've done, are going out to eat Ben & Jerry's chocolate therapy ice cream. What do you think? You see how this is just a different competing explanation for the same positive correlation? In one explanation, eating ice cream is making people homicidal, which is why you see this positive correlation moving in the same direction. The other explanation is that being homicidal is causing people to eat more ice cream, causing a positive correlation. What do you think? What do you think? What do you think? You think both of these explanations sound silly? Yeah, me too. And that's the problem with a simple correlation. It can't tell you why there's a relationship between ice cream sales and the murder rate. It can only tell you that there is one, right? So what's the most likely scenario here, right? Moving on to slide 15. The most likely scenario, and in fact the one established by a lot of really good research, is that it's the heat. It's what's called the third variable hypothesis. It's this idea that there is no cause and effect relationship between ice cream sales and the murder rate. If you could somehow control ice cream sales, and let's say you ban ice cream, that would have no effect on the murder rate. Or if you could somehow get people to engage in a lot of violent crime or stop them from having violent crime, that would have no effect on the ice cream sale rate. Because what's really happening here is that it's the heat, that it being sunny and hot out is not only making people more testy, getting people outside to interact with each other, tempers start to flare, and so, in fact, in hotter times of the year, violent crimes do in fact go up, as well as the ice cream sales. In hotter times of the year, people are more likely to want to go eat ice cream. And the reverse is true. When it's cold outside, people are less likely to want to eat ice cream and less likely to be outside interacting with one another with their tempers a-flaring in the heat, and then engaged in violent crime, right? Heat, believe it or not, actually is one thing that makes people aggressive. And so there's this third variable. There's a correlation between ice cream sales and the murder rate, but not a cause and effect relationship. So why do I teach this to you? Because it's important to recognize that if a researcher has done a correlational study, a true correlational study where they've systematically tracked people over time, And they've revealed a how relationship. How are these two variables related? That's good information. But it doesn't mean there's a cause and effect relationship. And so there's this saying that we have in psychology and in actually all the behavioral sciences. Correlation does not prove causation. Just because two variables are correlationally related, some systematic relationship out there in the world, doesn't mean there's a cause and effect relationship between the variables. And it's really important to recognize that correlation is not necessarily causation. Now, there might be a cause and effect relationship. For example, how much you study for your exam, I'm betting has a cause and effect relationship with your exam grades. If you study more, I bet that will cause you to have higher exam grades. But that's not necessarily the case. And you can't know that based just on the correlation. You can't, right? A correlation can only tell you how variables might be related. It can't tell you why. Right? So moving on to slide 16, please keep in mind, correlation is a hint. It's a little neon sign that says, hey, look here, there may be a cause and effect relationship. But it doesn't guarantee that there is one. There are so many things in the world that are correlationally related that do not have a cause and effect relationship. And if you simply do a correlational study, you can't establish a cause and effect relationship. Not for sure. No way. You have to do what's called a true experiment. And so moving on to slide 17, here's a joke. And if you really understand that correlation doesn't guarantee causation, you'll understand why this joke is funny. Once again, from my friend at XKCD. I used to think correlation implied causation. Then I took a statistics class. Now I don't. Sounds like the class helped. Well, maybe. Because couldn't this person be enrolled in a critical thinking class in addition to his or her statistics class? And maybe the critical thinking class was the reason this person learned this important life lesson or research lesson. So as a critical thinker, as you go out and move out in the world and you read research studies or you read news articles that say, Eureka, we found this relationship between this variable A and this variable B, ask the question, what kind of research study did you do? Did you do a correlational research? Well, then you can ask a how question. You can say how these variables are related, but you can't say why. And let me give you one example that I always see out there. A lot of times I see medical studies that say, oh my gosh, smoking marijuana causes brain changes, causes brain abnormalities. And although I'm in no way advocating for the use of marijuana, and I certainly accept that it might be true that smoking marijuana cause and effect, changes in the brain, I have yet to read a research study that simply wasn't correlational in nature, where they tracked how much marijuana people smoked and then tracked their brain activation rates or brain changes or brain differences. And what's the problem with this? The problem is it could be that it's the smoking of the marijuana that caused changes in the brain. Or it might be there are brains that are a little different, right? Maybe brains that are more likely to be risk-taking, that are more likely to then smoke marijuana. Or maybe it's a third thing altogether. Maybe it's not that the brains that are more likely to engage in risk-taking, differences in the brain, are leading you to smoke. Maybe it's some third thing altogether, like alcohol use, right? That people who are more likely to take risks, so have different types of brains, are in fact more likely to smoke marijuana, but it's really alcohol use that's causing further brain changes because they're more likely to use both things. It's just a complicated picture. And with a simple correlational study where you say, hey, look, people who smoke marijuana also seem to have these different brains, you don't know which it is. Is it the marijuana causing the brain differences? Is it the brain differences causing the marijuana? Or some third thing altogether, like poly drug use? It's really hard to say, right? It's really hard to say. So if you want to ask a why question, you'll have to do what's called a true experiment. And so this begins on slide 18. And so what do I have here? I have a little cute joke again, because I just love those, where it says, "That's right, Mr. Ferris. For the past 15 years, you've been the subject of a scientific study. This isn't your real home. I am not your wife, and that is a fake remote control." So that is what you need. If you want to know why two variables are related, A caused B, popularity caused aggression, marijuana caused brain changes, eating ice cream caused the homicide rate to spike. Whatever it is, you need to do a true experiment to establish that cause and effect relationship, or to establish that there isn't a cause and effect relationship, right? You got to get it there, and you got to manipulate things. And I don't mean manipulate in a bad way, moving on to slide 19, but I do like to think of a mad scientist because that's the essence. If you want to say A caused B, you as the researcher have to mess with A. If you want to say that smoking marijuana causes brains to be different, you think marijuana is the cause, then you as the researcher, have to get in there and manipulate how much marijuana people smoke. Because then you know for sure you made them smoke marijuana. And then if their brain changes, you can say for sure, yep, that marijuana was definitely the cause of that brain change. You have to get in there and manipulate things. And so I want to teach you about basic experimental manipulation. And it is the only way to establish a cause and effect relationship. True experimental research where the researcher manipulates some variable, some characteristic. And so that's why I like to think of Dr. Horrible, because that's Dr. Horrible there from Dr. Horrible's sing-along blog, which I also highly recommend, because I like to think of a mad scientist. A true experiment which allows you to say A caused B gets in there and manipulates the world. That's what it does. So to establish, and what does it manipulate? It manipulates whatever that researcher thinks is the cause. To then watch to see what happens on the effect, right? That's the idea. And there are three essential components. Now we're on slide 20. Three essential components to a true experiment. A true experiment begins with manipulation. If there's no manipulation, there is no experiment. And it's essential. The second thing is what's called control. We have to control the other aspects of our research participants' environment. If we can't control the other aspects of the research participants' environment, then we don't have a true experiment. The third thing is called random assignment. And this is one, because I'm going to teach you the basics of research methodology, and we're going to learn what's called a between groups true experiment, where you have random assignment. And so it's this kind of experiment that you're responsible for knowing. Are there other types of experiments out there? Yes, but we're going to stick with the most simple kind, where you have these three aspects of a true experiment: manipulation, control, and random assignment. And so what is manipulation? So, I mean, it's funny to laugh at people about the ice cream and homicide rate. Again, slide 21. But believe it or not, there is a correlation between ice cream sales and something else, where they actually mistakenly believed that there was a cause and effect relationship between the two variables. And this was ice cream sales and the polio infection rate. And in the 1930s and 40s, the medical community was tracking a correlation over the course of a year between ice cream sales and the polio infection rate. And they stumbled on this real correlation. And they speciously, which means incorrectly, believed that it was possible that eating ice cream was somehow causing polio infections to spike, right? It turns out it was the same third variable. It was the heat. But let's use this as a working example to say, well, how would I establish a cause and effect relationship between the polio infection rates and ice cream sales? How would I do this? Pardon me for putting my hair back up. It was falling down. How would I establish this cause and effect relationship? Well, if I wanted to establish eating ice cream alters polio infection rates, I would have to manipulate how much ice cream people eat. That is the cause. That is the input. And we call that then the independent variable. It's the cause. It's the input. It's the variable directly manipulated by the researcher. And so I like to imagine myself as the independent lord of my lab, deciding how much ice cream people eat. Since I'm the independent lord of my lab, manipulating how much ice cream people eat, I'm going to manipulate the independent variable because I'm independently deciding what things I'm manipulating. And so in this case, the independent variable is how much ice cream people eat. And so I'm going to, and because we're going to use the very basic, simple research design of what's called between groups, I'm going to create, let's say, 3 different groups. In the first group, I'm going to manipulate them and say, no ice cream for you. See how I've manipulated them? I've said whether or not you wanted to eat ice cream before, you're not allowed to now. No ice cream for you. Right? The second thing, the second group, I might say, a little bit of ice cream for you. Just a little bit of ice cream for you. Right? And then the third group, I'm going to manipulate and say, you're going to eat a gallon of ice cream every day for the next month, or however long I'm going to decide to make this study. And so you see, I've manipulated my people. I've created a variable here. The variable is how much ice cream did you eat? There are 3 different outcomes on that single variable. No ice cream, a little bit of ice cream, where everyone eats the same little bit, and then a lot of ice cream, where everybody eats the same large amount of ice cream. So I've created these 3 different outcomes. So I've created a human variable. The variable is how much ice cream did you eat as decided by Dr. Jenny, Lord of her lab. That is the independent variable. I manipulated it. Then I can see later on what effect did that have on my effect, my output, the thing I'm interested in tracking changes in, which is, in this case, polio infection rates, right? That would be my dependent variable because it depends on the fact that I already did a bunch of stuff, right? It depends on that. It's dependent on the fact that a bunch of manipulations have already occurred, right? We can't track polio infection rates until we have manipulated ice cream sales. So it's dependent. So you need to manipulate an independent variable. That is an essential component of a true experiment. A second necessary component is something called control. And this is where you make sure that, first of all, you make sure that the people who you told not eat ice cream don't actually eat any ice cream. You make sure the people who you compel to eat lots of ice cream actually eat lots of ice cream. So you tightly control the experience that your participant has. This is one of the reasons why true experiments often occur in a lab, where the researcher can control all the aspects of their research participant's environment for over the course of like an hour, where every participant experiences the same room, the same researcher. Every participant gets the exact same manipulation. They eat the exact same amount of ice cream. That way, because you've made everything else in the environment exactly the same, right? The room was the same, the temperature was the same, the researcher was the same, because every participant experienced the exact same situation except for the one thing you manipulated. If there are changes in the dependent variable, you can more confidently say, those changes were because of my manipulation. Those differences between my groups were because of my manipulation. And you can only do this if you have tight control. Because imagine if you create 3 different groups and you say you're going to eat no ice cream, and then you don't actually control what anybody does. And then they run off and eat just as much ice cream as they please, even though you put them in the no ice cream group. You can see how this would kind of blow up your study. And an example of a real research study that is often difficult to do, where control is an essential element, would be actually tracking watching violent television on children's aggression. This has a long and healthy research history of tracking violent television watching and then subsequently tracking children's aggressive impulses. And one of the things they had huge problems with when they first started doing this research, because they were trying to do a true experiment, right, was getting the kids, they said, don't watch television, to actually not watch television. And also to tightly control the rest of these children's environment so that they could look at just the effect of watching the violent television. Control was a problem. And there were several studies that got around this by doing studies in boarding schools or like summer camps, where they could actually tightly control everything that the children did day in and day out to try to effectively get experimental control, so that the only thing that differed from one person to another was the one thing you manipulated, your independent variable. Moving on to slide 23. The third essential component of a true experiment is called random assignment. And this is basically how you make sure, this is how you create your experimental groups. Because if we think back to manipulation, we can manipulate our groups by creating 3 of them. No ice cream, a little bit of ice cream, and a lot of ice cream. And we can do tight control. We make sure that our no ice cream people actually only eat 0 ounces of ice cream. We make sure that our little ice cream people actually eat 8 ounces of ice cream. We make sure our 16 ice cream, our large ice cream group really only eats 16 ounces of ice cream, and we control everything else in the person's environment. We make them live in a room, all of them in their own separate rooms for 6 weeks, whatever. Tight control. Random assignment is the idea that you have to give every person an equal likelihood of ending up into one of your 3 experimental groups. It's called random assignment. It's how you assign people to one of the groups. Now, this is not random sampling. That's how you get your sample. This assumes I already have a nice, good random sample. This is only if you're doing a true experiment. Then you need to randomly assign people to your different experimental groups. You can't put all the people who are sickly in the high ice cream group, right? And go, oh yes, eating lots of ice cream caused them to get polio. Well, no, it's because you stuck all the people who are likely to get sick in the high ice cream group. You have to sort of flip a coin and say, no matter what you're like in terms of your likelihood to get sick, genetically or whatever, I'm going to just randomly put you into one of these groups. And you're going to do this for all the people. That way, any sort of individual characteristics that these people have are going to be sort of equally ending up in all 3 groups. And so that any differences between the groups, you can confidently say is due to the ice cream that they ate. Random assignment is an essential component of what's called a between groups, which is the only kind I'm teaching you, true experiment. And so you need to know these 3 aspects of a true experiment. And so if we then sort of, in slide 24, use our ice cream on polio infection rates as a working example, let's explore how I would achieve these 3 essential elements of a true experiment. I'm going to do a manipulation, right, of an independent variable where I create 3 groups. I do tight control where I make one group only have 0 ounces of ice cream. I make a second group have only 8 ounces of ice cream, and I make a third group have 16 ounces of ice cream, right? And then I tightly control their living environment for however many weeks, let's say 6 weeks, where I make sure they don't have any different access to play groups. They have equal access to anything that might get them sick, right? I tightly control the environment. And then I randomly decide who's going to end up in each of my 3 groups. I flip a coin, or not a flip a coin, a random numbers generator. If you get a 2, you end up in the second group. If you get a 1, you end up in the first group. You get a 3, you end up in the third group. And so I have these 3 randomly assigned groups, right, that I tightly control for 6 weeks, that I have manipulated how much ice cream they eat. I've manipulated my independent variable. How much ice cream are you going to eat? Then later on, I measure my dependent variable, their polio infection rates. Then, if I find out that those who ate ice cream had greater polio infection rates, and better still, worse still, the people who ate even more ice cream had even higher polio infection rates, I can confidently say eating ice cream causes some change in polio infections. I have explained that how relationship. I already know that there's a positive relationship between ice cream sales and polio infection rates. If I can establish actually forcing people to eat ice cream increases polio, well then I've said why. I've now explained why there's a relationship between ice cream sales and the polio infection rate. I couldn't do that with a simple correlational study. Right? But of course that's a silly example. In fact, there is not a cause and effect relationship between ice cream sales and polio infection rates. It was the same third variable they discovered. It was the heat. Kids were more likely to get polio in the summer when they were interacting with other children who may have been exposed to polio. And infectious diseases, oof, they just love the heat, especially ones like polio. So, yeah, there was no cause and effect relationship. It was the 3rd variable of heat once again, just like with ice cream sales and the murder rate. So then slide 25, I want to give you an actual real world example of a real true experiment and how these researchers were able to establish a cause and effect relationship between two different variables. So there's this thing called the Pygmalion effect, and it's this idea of a self-fulfilling prophecy. And so I want you to think about society, and I want you to ask yourself this question. Do you think there are some people for whom there are high expectations? Children who grow up in families and with teachers who believe in them, who believe that they are going to succeed, who believe that they are going to go to college, have high expectations. Do you think that there are other children who grow up in environments where people have low expectations about them? Their parents don't think that they can succeed. Their teachers don't believe that they're going to be successful or go on to college. Now, and then ask yourself this. Do these expectations themselves lead to different outcomes? Because you might argue, well, yeah, there are some kids that just aren't any good, and of course we have low expectations of them. And there are some kids that are just awesome, and of course we have high expectations of them. But could there be a cause and effect relationship where it's the expectations themselves that become a self-fulfilling prophecy, where the expectations of low success actually lead to low success, or the expectations of high success actually lead to high success? And here are two researchers back in the 60s who did a true experiment to sort of ask this question. Is there a cause and effect relationship between expectations and people's success? And in order to test this question, they had to manipulate people's expectations. And so they did just that. They went into real-world classrooms and they told the teachers, with the cooperation of the principals, right? They told the teachers, we gave all of your students an IQ test. We gave all of your students a test of academic potential, is what they said. And it turns out some of your kids are bloomers, meaning even though you haven't seen great things from them yet, you will see great things. They're going to be fantastic as the year goes on. They're going to really bloom. And the other kids, they're not unfortunate, but they're just not bloomers. They're just typical kids, right? They didn't actually tell any of these teachers that the kids were stupid. Nothing like that. But what they basically said is you have a bunch of typical kids in your class, but you have some special kids too. Some really exceptional kids. I know they haven't seemed exceptional thus far, but according to our testing, they're bloomer kids. And in reality, this manipulated independent variable was completely randomly assigned, right? Which kid was given the bloomer label and which kid was given the non-bloomer label was completely randomly assigned, right? There was no difference between these two groups of children, right? And all the kids were in the same environment, same teacher, same school, and so that was their attempt at control, right? They made sure the teachers had these expectations, and they had these kids be in the same environment. And so the dependent variable at the end of the year was not only how they were doing in class, right? Because maybe if the teachers expected them to do better, they graded them easier, but they did better on standardized tests. They did better on IQ tests, on things that had absolutely nothing to do with the class itself, on these external measures, right? And so the dependent variable was how well they were doing in terms of all intellectual performance at the end of the year. And so slide 26 shows or talks about this idea that those students who the experimentals randomly labeled as bloomer kids, who would bloom like flowers over the course of the year, were actually doing better. Now, was this magical? Was this a magical label? No. I mean, we can sort of more research would need to be done at this point, which is why science is never done. We don't, but we can say why these kids were doing better. At least one of the reasons. They were doing better because of their teachers' expectations. We can make a cause and effect statement. We can say, giving the teacher high expectations of these students caused those students to do better. Now, why did the expectations lead those students to do better? That's still an open question, which is why research is never done. But we can definitely say that those expectations led those children to do better. And further research has established how this happens. Basically, those teachers treated those children as if they were already doing well. They were calling on them more, spending more time with them, giving them more enriched materials. And so they actually brought about the very expectations that they had by treating these children as if they were already bloomed, and in doing so, created blooming children. And while this is a super cool study, I want you to know, recognize it as an example of a researcher establishing a cause and effect relationship that you can now say definitively, or at least you can say this one research study, there have been many that back it up, just so you know, this one research study establishes a cause and effect relationship. Having high expectations causes students to do better. That was, you can say that because this was a true experiment that was able to answer a why question. Here's another study in a completely different area. This looked at oxytocin therapy on autism-related symptoms. Now, I'm not an autism expert, so don't come run into me and say, where can I get oxytocin? I'm just sharing with you research findings and how researchers established a cause and effect relationship. So what they manipulated in adults living with autism was whether or not they got this brain chemical, this sort of synthetic brain chemical called oxytocin. It naturally occurs in the brain, but you can give it people synthetically, and that's what they did. They split up their groups into two. Again, we've got manipulation, right, where they manipulated whether or not their adults with autism patients either got this real oxytocin nasal spray or whether or not they got a placebo. And so again, you've got manipulation. And of course, they tightly controlled the environment to the best that they could. And then and they randomly decided which people were going to get the oxytocin and which people were going to get the placebo. A placebo is like saline or salt water. You think it's the drug, but there's no drug, right? It's called a placebo. The dependent variable was something called, was basically their brain activation patterns. There's a part of the brain that regulates sort of fear, and it's called the amygdala. And so they measured how much response there was in the fear parts of the brain. And what they found, and they also then tracked their autism-related behaviors. There are some symptoms of autism. And so slide 28 sort of discusses their findings. What they found was that the people who got the oxytocin had lower amygdala activity. So the part of the brain that regulates fear was sort of had less activation. And so there's some theory that states that possibly some of the things that goes on with autism is an overactive amygdala, an overactive fear part of the brain, particularly when interacting with other people. And not only did they show lower amygdala activity, but they also showed an improvement in a wide variety of autism-related behaviors. So yes, this is a cool study. I want you to know it. But also recognize that these researchers were attempting to establish a cause and effect relationship by manipulating whether or not people got oxytocin, randomly assigning people to one of the two groups, right? That independent variable. They've created a variable. Did you get oxytocin or not is the variable. Two outcomes. Yes, I got oxytocin. No, I didn't, right? And then it's a medical study, so I'm sure they tightly controlled the environment, right? And because of that, they were able to then establish that taking oxytocin is cause and effect related to this this improvement of symptoms, right? And so that is the beauty of a true experiment, is being able to establish cause and effect relationships. So slide 29. So just like there were good things about observational research and some bad things, there are some good things and bad things about experimental designs as well. It has what's called good internal validity, which isn't on the slide, but you can just write that down. It's got good internal validity. That means once you've established a cause and effect relationship and it's been replicated by somebody else, right, because you should probably replicate it, you can say A caused B, at least in the lab, at least under these conditions. And so it allows for cause and effect relationships. You can say A causes B, at least sometimes under some conditions. And so you can make predictions about the world. If we give people oxytocin, we can predict their autism-related behaviors might improve, right? At least on average in general. But there are some downsides. And the downsides is that, well, first of all, you can't do a true experiment on all the things, right? If I really believe that ice cream is related causally to the murder rate, I am not going to manipulate how much ice cream people eat. If I really think ice cream is leading to greater polio infection rates, I am not going to give people ice cream to watch what happens to their polio infection rates, right? Not all questions are what are called amenable. Not all questions can be explored experimentally. It's just the downside, right? Also, oftentimes true experiments, because you need to have tight control, lack external validity. Because you have to bring people into the lab and tightly control their environments, it's possible that the cause and effect relationship that you found really only works in that very artificial environment that you created with your true experiment. And maybe in the real world, it doesn't actually work that way, which is why you need to not only have what are called lab studies, but also field studies, where you go into the real world and you see if the same effect happens, the same sort of cause and effect happens. Right? Do a true experiment in the lab and then go in the real world and see if the same basic pattern holds with real people, right? Another problem with true experiments is oftentimes we have sampling problems, particularly in psychology, where the people who we can do a true experiment on are not like a nice cross-section of the whole population, but only the college students that we can coerce to come into our lab. And so it's not that I'll take a breath. The downsides of a true experiment are, although it is what you need to have to establish a cause and effect relationship, not all questions can be asked this way or addressed this way. And oftentimes, not often, but sometimes, even though you can establish a cause and effect relationship in the lab, that cause and effect relationship may not actually translate into real world situations. And sometimes the people we're able to do true experiments on don't actually reflect the larger population we're hoping to ask questions about. It's just sort of the pros and cons. And so taken together, we have these three broad approaches to research methods. And one is not better than the other. They just address different kinds of questions. Observational research addresses a what question. What is this characteristic like? Correlational research addresses a how question. How are variables related? And true experiments address a why question. Why might these variables be related in a cause and effect way? And so as a critical thinker, I give you this as a tool for your toolbox. That if you're reading a research article out there, ask yourself, what kind of question did this researcher design for? Did they simply do an observational study? Well, then they can only ask a what question. Did they design a correlational study? Then they can ask a how question. Or did they design a true experiment? They can ask a why question, but I better be careful because this cause and effect relationship may or may not hold in the real world depending on how the researcher did their study. The last topic I want you to think about, and now for something related to our current discussion, but a little bit different, right? So the last thing I want you to think about is once you've established a cause and effect relationship, right? Once you've established that, I don't know, let's say I'm able to manipulate popularity, right? Let's say I'm able to manipulate popularity. I can make a bunch of kids popular, right? And let's say I notice that once they become popular, and I've randomly assigned kids to my groups, you're going to be popular, I can somehow manipulate that, and you're going to be unpopular, I can somehow manipulate that. And then if I notice the kids that I manipulated into being popular then suddenly become more aggressive, and the kids that I manipulated not to be popular, well, then I can establish the cause and effect relationship between popularity and aggression. But my job is not done. Because not all causes are created equal. Not all causes are created equal. And I want to talk about the difference between what's called a necessary and a sufficient cause, or a necessary or sufficient condition. A condition is another word for cause. There's a condition under which something will happen. Condition is a synonym for cause, right? So if I want to say popularity causes aggression, then I'm saying popularity is a condition under which aggression can or will occur. There are different kinds of causes. They're what are called necessary causes, meaning without that cause, that effect will never occur. It is necessary. That's different than something called a sufficient condition. And a sufficient condition is one where if that cause happens, that effect will definitely occur. And these are two separate questions to ask yourself about any particular cause. There are some causes that can be both necessary and sufficient. There are some causes that are neither necessary or sufficient, although they can, in some situations, lead to an effect. And there are some conditions, some causes that are only necessary and some that are only sufficient. There's all these combinations that you can have. So let me give you an example. So let's think about like being alive is the effect. Being alive has some necessary causes, right? None of them is sufficient by themselves, though. Like if I want to be alive, I'm going to have to eat. That is totally necessary, but not sufficient by itself. If I want to be alive, I have to breathe oxygen. Totally necessary, but not sufficient. If I want to be alive, I have to drink water. Now, if I put those three things together, water, food, breathing, now I've got the necessary cocktail of ingredients to keep being alive, right? But by themselves, none of those is sufficient. Collectively, I've created a sufficient condition to be alive, right? That's an example of the interplay between necessary versus sufficient. And so let's think of other things that might just be sufficient but not necessary. There are probably lots of things that can put you in a good mood, right? They're sufficient, but they're not necessary, right? Like watching a movie I like is sufficient to put me in a good mood. It's not necessary, but it's totally sufficient. There are, getting a new pair of shoes is totally sufficient to make me happy, but not at all necessary, right? So that's the idea that some causes can be sufficient, but not necessary. Let's think about things that are necessary and sufficient. You need them, and they are totally sufficient all by themselves to cause the effect. Let's think about genes, right? Genes are are often necessary and sufficient. For example, the gene for blue eyes. It's actually a broken brown gene. If you get basically genes from your mothers and fathers, right? And in order to have brown eyes, it is necessary that you have a brown-eyed gene, a non-broken brown-eyed gene. And if you have a non-broken brown-eyed gene, you will in fact have brown eyes all the time, unquestionably. But without a brown-eyed gene, you also can't have brown eyes. So the brown-eyed gene is both necessary and sufficient. If you've got one, either from your mom or your dad, you will definitely have brown eyes. And if you don't have one, you definitely won't have brown eyes, right? So it's both necessary, needful, and sufficient, right? And then there are some causes that are neither, right? It's not necessary, nor is it sufficient. So let's talk about I don't know, things that might make a person unhappy, right? Let's say in the morning I wake up and it's cloudy out. Now that is not necessarily going to make me unhappy. It's cloudy out. Okay, it's cloudy out. And it's certainly not sufficient, right? Like if it's cloudy out, I'm not going to boom suddenly be unhappy. And in order for me to be sad, I do not need it to be sunny out, right? Okay, but it is cloudy out. Let's start over. So let's use the example of making me sad. I wake up and it's cloudy out. That is not necessary to put me in a bad mood, right? There are lots of things that can instantaneously put me in a bad mood, having nothing to do with the clouds outside, right? It's also not sufficient. Just because I wake up and it's cloudy outside is not sufficient to make me unhappy, right? Certainly not necessary and not sufficient. But then it's cloudy out and I get in my car and my car won't start. Now, if my car doesn't start, that's not necessary in order to make me unhappy. There are lots of things that can make me unhappy. It's also not sufficient. I mean, just because my car doesn't start doesn't mean I'm going to have a terrible day. But now it's cloudy out and my car won't start. And let's say I decided to take the bus then because my car wouldn't start and the bus is late. Okay. Now, the bus being late was not necessary to make me unhappy. Other things can make me unhappy. And by itself, it wasn't sufficient. But get these three things together, and now I'm a very unhappy camper, right? And so I can say that the bus being late can cause me to be unhappy, but not by itself So it's not sufficient and it's not necessary. And so that's the idea behind necessary versus sufficient. Because if you want to make good predictions about the world, it's important to recognize that sometimes, even though you can establish a cause and effect relationship between variables, sometimes variables have to work together to have some effect, right? Because none of them are sufficient. And sometimes some causes are completely necessary and sufficient. Sometimes there's some combination of these different ideas. And so think about it. And so a working example that I want to share with you on slide 31 is research that was conducted on something called on desegregation, right? Research on desegregation. And it was done by a man named Allport. And he was one of the people who basically, there was this court case back in the 1950s called Brown versus the Board of Education. And essentially, there were a bunch of social psychologists who wrote a brief to the court that basically said segregated schools are by definition not equal. By definition, they're totally not equal. And you're actually harming the students who are segregated. So you need to desegregate schools because that will at least be a good first step to social justice and a good first step to intergroup harmony. But this really unfortunate thing happened once and the Supreme Court did rule that segregation, forced segregation, was by definition unequal and not okay, at least in schools. And so, and that's just great. It's a win for social justice. But this really unfortunate thing happened. What was discovered was that desegregating the schools led to this really unfortunate unintended consequence. It actually led to increased intergroup hostility between kids of different ethnic backgrounds. Negative attitudes went up about the members of the outside group. So let's think about white kids and black kids. Essentially what they found was when you desegregated the schools, intergroup, so the interactions, intergroup, like interaction, the intergroup interaction between the white kids and the black kids got worse. They actually were more likely to get into tussles and more likely to have inaccurate beliefs. And so what was that all about? And so what it was discovered through a long line of research was that desegregation, although necessary, this is called the contact hypothesis, that if you want groups to get along, they will in fact have to be in contact, but that is necessary. But it is not by any stretch of the imagination sufficient. That if you want groups to get along, cause and effect, will desegregating kids cause kids to have more intergroup harmony? Well, it can, but not always. That desegregation in and of itself, mere contact in and of itself is not enough. It's not enough to ensure intergroup harmony, right? And so this is just a deeper question that researchers have to ask themselves. If you can establish a cause and effect relationship, right, is that cause sufficient? Is that cause necessary? Is it some combination of necessary and sufficient? And so what they discovered then is that there are actually four, count them, four necessary conditions, four necessary causes that if you put them together actually can lead to improvements in intergroup cooperation. And the first one is contact, right? Is you actually have intergroup contact, intergroup interaction, actual interaction between the groups, right? And with that, an actual meaningful interaction, where it's not simply that they're walking by each other in the hall, but they're actually talking to one another and having what's called meaningful interaction, where they're finding out about one another. That is first and foremost what you need: actual contact, actual meaningful interaction. But that's not enough. The second thing research has discovered is needed for groups to actually benefit from desegregation is cooperation. You have to actually give them a shared goal that they both want, that they're cooperating towards. It's what's called a superordinate goal. whatever. Superordinate just means higher, meaning it means higher than them both. They need to be working towards something together that they both care about. Like they have to work together on a group project. They have to work together to build a wall, work together to plant a garden, where both groups, members of both groups, are equally invested in this goal, right? So a shared goal where they will actually cooperate is the second necessary condition for desegregation to have positive effects. The third thing is called equal status. And that's the idea that when you get them together in contact, when you give them a shared goal, you have to give the members of both groups equal status in the interaction. Meaning, let's say they're going to plant a garden together because the school is going to have a community garden. You would not have positive effects of desegregation if you decided to put the white kids in charge telling the black kids what to do, or vice versa, right? Or let's say it's a group project. It wouldn't, the desegregated group project would not actually show any improvement in intergroup relationships if you make the white kids in charge, make them the tutors, and make the black kids the tutees, right? That would not be a good thing. That in whatever goal you've given them, you have to give all the members of the group equal status. And the last thing is what's called the sanction of authority. The sanction of authority. And this is the fourth necessary condition in order for intergroup contact to create a sufficient recipe to result in the effect you want, which in this case is intergroup harmony, intergroup sort of improvement of relationships. And the sanction of authority is the idea that whoever these kids look up to, whoever these kids see as a legitimate authority in their lives, older siblings, their parents, their teachers, community members whom they respect, church leaders, whoever these kids see as legitimate authority figures need to buy in to the desegregation efforts. They have to say, yes, desegregation is a good thing. I want you to have positive intergroup relationships. And so that is the fourth necessary condition in order for desegregation to have the effect that you want. And so if you take these four together, in summary, if you want desegregation as a cause to actually lead to intergroup harmony, you will in fact have to have the kids interact with one another, contact. You need to give them some shared goal so that they will cooperate. You need to give all the members of the group equal status, meaning the black kids, white kids, brown kids, insert color here, right, have equal responsibility, have equal positive outcomes, they have equal status in this interaction, whether it's a garden or a wall or a project or a song or whatever, right? And the sanction of authority, meaning the people those kids respect support the interaction. And I think a good real-world example of this is sports teams, right? A lot of times in sports teams, you end up with these four conditions sort of happening naturally. And in fact, sports were one of the very first places where you saw a lot of really positive effects of desegregation. And I think just because of the very nature of sports, you end up with these four conditions happening just as a product of the way sports is done. And if you look at the history of sport, baseball, basketball, football, you actually see a lot of improvement in intergroup attitudes, attitudes about white folks and black folks and brown folks improving among the players, which I think really speaks to sort of the power of this model. And this model was, again, championed by a man named Gordon Allport, who was one of those guys who originally championed for desegregation. Modern incarnations of this research include the jigsaw classroom, which is championed by a researcher named Elliot Aronson. So if you want to sort of look at modern research that sort of looks at this, I would encourage you to do that. But how it relates to our current discussion is a good critical thinker is familiar with research studies, is familiar with the kind of questions those research studies can ask and answer. Can it ask a what question, a how question, a why question? But even if it asks a why question, your job is still not done. Because just because there is a cause and effect relationship, is that cause necessary? Is that cause sufficient? I don't know. which is why we don't end up with just like 12 research studies and then we say we know the world, right? Research is really a never-ending process of building on what other people have discovered. And so our last thing I want to leave you with is just to think more about this cause and effect and different causes. There's this saying that it says that holding elections is necessary, but not sufficient for establishing a democracy. And so use that as a working example to sort of explore this idea more for yourself. Can you come up with, for yourself, some cause and effect relationships that you think are necessary, but by themselves not sufficient, right? And can you create a cocktail, like our cocktail for desegregation leading to harmony, our cocktail for the ingredients for life leading me to stay alive, water, food, and oxygen will keep me alive in the next 5 minutes, right? Or keep me alive for the next 3 days, right? Can you sort of explore this idea of what are the necessary conditions in order to create the sufficient condition for which you could say you have a functional democracy? And that's it for our topic for today, research methodology. I will see you next time. Have a good one.